Hi, Catherine.
Hey Elisa, shall we begin our study session?
Sure. What was the quiz about again? I forgot.
Um, I think it's about sinusoidal frequency analysis. Do you understand the material?
Oh, I only understand some. For example, like the sinusoidal, the response to sinusoidal input. However, I don't quite understand bot plots. How about you?
Same, I only understand a few as well, like body plots. Would you teach me about response to sinusoidal input while I teach you about body plots?
That sounds great. Shall I start first?
Sure.
I remember we've made a slide about it before. Let me open it.
Okay.
So this is the slide for the sinusoidal frequency analysis, where we talk about response to sinusoidal input and dot plots. So we will talk about the first one, which is sinusoidal input. So the convolution system with impulse response h transfers function h. We can then describe the system like in this picture. The sinusoidal input will be as such, meanwhile the output as such. Then we can put it into an equation like this. So in the first term, it is called sinusoidal steady state response. Meanwhile, on the second term, if it decays with t, then the system is stable. Then, if it decays, we can also call the system a transient. So, assuming that the system is stable, sinusoidal steady state response can be expressed through this equation, where we will break it down until we get this equation, where A is as such. Now, to conclude of the previous equation, we can conclude them as such. If the convolution system is stable, the response to a sinusoidal input is asymptotically sinusoidal with the same frequency as the input and with magnitude and phase determined by hj omega. Magnitude hj omega gives amplification factor like RMS YSS or RMS U. Phase angle hj omega gives phase shift between U and YSS. However, there is a special case. Well, where UT is equal to 1 and the omega is equal to 0. The output will then converges to H0 with a DC gain. Here is an example to help us understand the theory a bit more. In here, UT is expressed as the dashed line, meanwhile YT is expressed as the solid line. The transfer function is HS equals to 1 over S plus 1. Input UT is expressed as cos t, as output has magnitude Hj equals to 1 over square 2, and the phase Hj is minus 45 degree. So for if we assume the system is stable, and the input is asymptotically sinusoidal, we can gather this equation. As t is infinite, then we will get this equation. Now, as t is infinite again, we will after that gain this equation where YSS is equal to Hj omega u. If we want to find the value of Hj omega, we can do so by dividing YSS with U. Now, in a stable system, Hj omega gives ratio of phasors of asymptotic sinusoidal output and input. So with assuming that a system is stable, we can conclude as such. Hj omega large mean asymptotic response of systems to sinusoid with frequency omega is large. H0 equals to 2 which means asymptotic response to constant signal is twice the input value. Hj omega small for large omega means the asymptotic output for high frequency sinusoid is small.
Wow, thank you. I understand it a bit better now. Shall we move on to the body plots now?
Sure, I can wait to hear your explanation about it.
Okay, there are three elements that important in body plots. First is frequency axis, second is magnitude, and the last is phase angle. Frequency axis logarithmic scale for omega. Horizontal descent represents a fixed frequency ratio or factor. Ratio 2 to 1 is called an octave, and ratio 10 to 1 is called a decade. Magnitude expressed in decibel, for example, 20 log 10 h j omega. Vertical distance represents decibel for example, a fixed ratio of magnitude ratio 2 to 1 is plus 6 decibel, ratio 10 to 1 is plus 20 decibel. Steps are given in units such as decibel over octave or decibel over decade. For the phase, multiple of 360 degree. Phase what is called wave when phase are between plus minus 180 degree or 0.360 degree is called unwrap if multiple of 360 degree is chosen to make a phase plot continuous. Next. Now we move on to the border plots product. Consider product of transfer function H is equal to Fg. Frequency response magnitude and phase are 20 log 10 H j omega is equal to 20 log 10 F j omega plus 20 log 10 G j omega. The angle H j omega is equal to the angle F j omega plus angle G j omega. Here we use the fact that angle AB is equal to angle A plus angle B. So the plot of a product is the sum of the plots of each term. Okay. Here's an example to help you understand the body plots better. So for example, fx function is equal to 1 over s plus 10 and gs function is equal to 1 plus 1 over s. There are several body plots provided to help us. The first one is 20 log 10 f and the second one is about the base angle of f. Well, these two body plots is the same as before, however we just change it from f to g. From that, we will get the result hs function is equal to fs function times gs function. So it's equal to 1 plus 1 over s divided by s plus 10. And it's equal to s plus 1 over s times s plus 10.
Wow, thank you so much, Catherine. I think I finally understand bot plots a bit better now.
Me too. Shall we continue our study session next time?
Sure, I need to go do some homework anyways. So, see you tomorrow.
Bye.